Graphing absolute value functions. After this lesson, you'll be able to graph an absolute value function from a table, and you'll be able to graph an absolute value graph from using key features. So we're going to first talk about how to graph using a table. The first step is to identify the vertex from the function and enter it into the t-table. Then you're going to choose the next 3 sequential, that means in order, values for x. Then you're going to draw a dashed line for the axis of symmetry. That's that middle line where you can fold it in half. You're going to plot all the points, and you're going to reflect the points across the axis of symmetry. So pause the video if you need more time to be able to write down these notes. We're going to dive into an example. So taking a look at example 1, we first need to identify the vertex. So I know my vertex is at HK, where I remember that X is lying to you about the sign. So I see a 7 is going to be my vertex X value, and a 2 is going to be my vertex Y value. So I'm going to go ahead and put that 7 and 2 in my t-table. The next step is to find the next 3 sequential X values. So from 7, we go to 8, 9, and 10. The next thing I'm going to do is, my Y terms are also going to go sequential. So I go from 2 to 3 to 4 to 5. And I'm going to go ahead and plot those points. So I have from 7 to 2. And I'm going to do the points 8 and 3, 9 and 4, 10 and 5. My axis of symmetry is right through my vertex. So then I'm going to go, if this was 1 away, I'm going to go 1 away here. If this was 2 away, I'm going to go 2 away here. If this was 3 away, I'm going to go 3 away here. That's how we get our V shape. Connect our dots. Hopefully your line is significantly straighter than mine. And there's our graph using the t-table. Pause the video now as you try example 2. We're going to go ahead and scratch out this 2 right here. So everyone on your paper, scratch out this 2. Try your best to do example 2. Check your work. Be amazing. So the first step is finding our vertex, which in this case would be at -3, -6. And then we find our next sequential values, -2, -1, 0, -5, -4, and -3. It might have been a little hard with the negatives because remember, if we're increasing, we're actually getting to kind of look like a smaller number. So I'm going to be at -3, -6. And then I'm going to be at -2, -5. Here we go. And 0, -3. I draw my axis of symmetry. And I do, if this was 1 away, this will be 1 away. If this was 2 away, we're going to be 2 away. 3 away, we're going to be 3 away. Connect our dots. And there's the most beautiful graph that you have ever seen. Try your best on example 3. Keep in mind that because it's a negative, your sequential values are actually going to be the decreasing value. Decreasing, because this would be downward facing. So we know our vertex is at -2, -5. And again, I've got a decrease. So I'm actually going to go to -3, -4, -5, -6, -7, and -8. So I'm at -2, -5, -3, -6, and so on until I get to -5, -8. Axis of symmetry. And I reflect across equal distance. There we have our absolute value graph. Notice how it's pointing downward because we have that negative out in front. Now we're going to talk about graphing absolute values using the key features. The first thing I'd like you to do is please identify the vertex, axis of symmetry, y-intercept, and x-intercepts of this function. Check your work, then graph. So our vertex, my x value lies, so it's a -2, and we have a -2. So that's going to be, because Well, we haven't graphed it yet, so we don't know if it's a max or a min. So then our axis of symmetry is always the x value at x equals -2. My y-intercept is where x equals 0, so I'm going to plug in, and I'm going to get y equals the absolute value of 0 plus 2 minus 2. I continue to solve. 0 plus 2 gives me the absolute value of 2 minus 2. So then I end up with 2 minus 2, which is 0. So I know I'm at the point 0, 0 for my y-intercept. For my x-intercept, I'm going to say that y is 0, which means I'm setting the entire function equal to 0 and solving. So the first thing I do is add 2 to both sides of the equation, and I get 2 equals the absolute value of x plus 2. And then I set up my problem to have x plus 2 equals the positive answer and x plus 2 equals the negative answer. For both of these, I would subtract 2 to solve, and I'm going to get x equals 0. So my first x-intercept is at the point 0, 0, which makes sense, because if it goes through there at the y, it's also going to go there at the x. But here I have -2 minus 2, so I get x equals -4 as my second x-intercept. Now, to graph using the features, go ahead and graph your 3 main points, as well as your axis of symmetry. We have -2, -2 for our vertex. We have the origin is both my y-intercept and one of my x-intercepts. And then I have -4 as my other one. And my axis of symmetry is going right through my vertex. I connect my dots, and there is my beautiful graph. Try your best to find all of the key features of example 5 and graph. You got this. So the first thing I want to do is find my vertex, which my vertex is always the HK. There's nothing inside here, so I know it's like I'm adding 0 plus 6. My axis of symmetry is always my x value of my vertex. For my y-intercept, I know that x equals 0, so I'm going to do y equals negative absolute value of 0 plus 6. Y equals negative, well, the absolute value of 0 is 0. Was there any such thing as a -0? Not really. So really we end up with y equals 6. So our y-intercept is at the point 0, 6. Notice how it's the same as our vertex. And that's okay that they're the same point. For my x-intercept, I know that I'm working with y equals 0. So I'm going to set the entire function equal to 0. My first step would be to subtract 6 on both sides. Now you might be thinking, whoa, 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 we can't have a negative equal to an absolute value. But keep in mind that we actually have this -1 out in front. It's touching, so it's multiplying, so we're going to divide both sides by -1. We get the absolute value of x to equal positive 6. So I set up my two equations, x equals 6 and x equals -6. So my two x-intercepts are 6, 0 and -6, 0. So let's plot all of our points. 0, 6. That's both my vertex and my y-intercept, which is totally okay. Get my axis of symmetry. And I get both of my x-intercepts. My last step is to connect the dots. And it makes sense that this would be downward facing because we had a negative out front. Try your best at example 6. Find the key features. Graph that graph. So our vertex is at the point 2, -7. Ooh, just kidding. Don't make that mistake that Miss Coates just made. Keep in mind, guys, only the x changes sides. The x lies, just like why you broke up. We get x equals +2 and +7. Only change one of them. My line of symmetry is x equals 2. My y-intercept is where x is 0, so I'm going to plug a 0 in. y is the absolute value of 0 minus 2 plus 7. My absolute value ends up being negative 2. When I take the absolute value, I get 2. I add 7, and I get 9. So my y-intercept is going to be the point 0, 9. For my x-intercept, I know I'm working with y equals 0. So I'm going to set the entire function equal to 0. X plus 2 inside the absolute value, plus 7. I'm going to subtract 7 on both sides, and I'm going to get negative 7 equals the absolute value of x plus 2. We can't have that. An absolute value cannot equal a negative. There is no negative out in front to save it. An absolute value cannot equal a negative, so there is no x-intercept. So we plot the points that we do have, which is 2, 7, and the point 0, 9. And we have nothing else to graph. So to finish this one, I am going to connect from my vertex to my y-intercept, but I actually need my axis of symmetry to plot my other point. So if my y-intercept is 2 away from the axis of symmetry, I'm going to go 2 this direction. And that's how I'm going to finish graphing. Notice how it has no x-intercepts because it does not cross the x-axis. And that's your graph using the key features. Great job getting through these notes. Do your best on the practice, and never forget how awesome you truly are.